Hello friends. Welcome back to my YouTube channel. Today we embark on an exciting journey to uncover the fascinating mystery of electrical arc formation in power system circuit breakers, and explore the innovative ways to extinguish these arc. Electrical arc is formed whenever potential difference between two separated conductors is above the dielectric strength of the medium. It is important to know that every medium such as air, vacuum, or oil can be ionized and forms a conducting path at very high voltage. At such high voltage the medium loses its insulation properties and behaves like a virtual conductor. In circuit breakers this medium serves as arc quenching medium. But unfortunately, when the contacts of circuit breakers open during fault condition, the high potential difference is established between the contacts. At this point, the medium between them tends to ionize and continue passing fault current across the contacts to system, leading to damage risk. This phenomenon of arc forming between contacts even when the circuit breaker is open is a serious problem in high voltage systems. Now that we are aware of the risks associated with arcs in power systems, how can we reduce it? This leads us to today's topic called arc extinction. Now relax. Let us explore it in detail. Welcome back. If you are new to my YouTube channel, please support the channel by sharing and subscribing to the channel. You can also hit the subscription button to get updated in all my latest videos on power systems. Thank you for your support. Let us proceed. First, what do we actually mean by arc extinction? Arc extinction refers to the process of extinguishing an electrical arc that forms between the contacts of a circuit breaker when it opens or closes. An electrical arc is a self-sustaining electrical discharge that occurs when the contacts of a circuit breaker are separated or closed. This can cause significant damage to the breaker and other equipment. Arc extinction is a critical function of circuit breakers, as it enables them to safely and reliably interrupt electrical circuits. The importance of arc extinction in circuit breakers cannot be overstated. If an arc is not extinguished properly, it can lead to a range of problems, including overheating, equipment damage, and even electrical fires. Arc extinction is essential for ensuring the safe and reliable operation of circuit breakers. Now that we have understood arc extinction, let us examine the techniques or methods used to achieve it. There are several methods of arc extinction, each with its own strengths and weaknesses. The first method we will look at is high resistance method. The high-resistance method of arc extinction is a widely used technique for extinguishing electrical arcs in circuit breakers. This method works on the principle that an electrical arc is a resistive load, and by increasing the resistance of the arc path, the current flowing through the arc medium can be reduced. As the resistance increases, the voltage drop across the arc also increases. This in turn reduces the arcing current. By increasing the resistance sufficiently, the current can be reduced to a point where the arc is extinguished. This high-resistance method can be achieved through various means, including: Number 1. Increasing the length of the arc. This technique is used to increase the arc voltage and reduce the current, making it easier to extinguish. When the arc is lengthened, the resistance of the arc path increases, which in turn increases the voltage drop across the arc. This reduces the current flowing through the arc, making it more susceptible to extinction. Increasing the length of the arc can be achieved through various means, including designing the circuit breaker contacts to move apart rapidly, or using arc chute or arc splitter plates. Second technique is introducing high-resistance materials. High-resistance materials, such as arc chute or arc splitter plates, can be introduced into the arc path to increase the resistance. These materials can be designed to withstand the high temperatures and energies associated with electrical arcs. Third technique is cooling the arc medium. Cooling the arc is a technique used to reduce the arc's energy and help extinguish it more quickly. When the arc is cooled, the energy dissipated by the arc is reduced, making it easier to extinguish. Cooling the arc can be achieved through various means, including using arc chute or arc splitter plates, which can help to dissipate the arc energy. Cooling the arc can also be achieved through the use of cooling gases or liquids. Fourth technique is using arc quenching materials. Arc quenching materials, such as silica or alumina, can be used to extinguish the arc. These materials can be designed to absorb the energy of the arc, reducing the current and ultimately extinguishing the arc. The last technique is splitting the arc. Splitting the arc into multiple smaller arcs is a technique used to extinguish it more quickly and efficiently. When the arc is split, the energy dissipated by each smaller arc is reduced, making it easier to extinguish. Splitting the arc can be achieved through various means, including using arc splitter plates, or designing the circuit breaker contacts to split the arc. Now that we have exhausted high-resistance arc extinction technique, let us explore the benefits of the high-resistance method. This method of arc extinction has several advantages. This includes 1. Simple and reliable. The high-resistance method is a simple and reliable technique for extinguishing electrical arcs. 2. Effective for low-voltage applications. The high-resistance method is effective for low-voltage applications, where the arc energies are relatively low. 3. Low maintenance. The high-resistance method requires minimal maintenance, as it does not involve complex mechanisms or moving parts. Having covered the benefits of high-resistance arc extinction technique, let us analyze the drawbacks of this method. This method also has some disadvantages. These include the followings. 1. Limited effectiveness for high-voltage applications. The high-resistance method may not be suitable for high-voltage applications, where the arc energies are high. The arc is more difficult to extinguish. 2. Increased contact wear. The high-resistance method can result in increased contact wear, as the arc can cause erosion and degradation of the contact surfaces. 3. Potential for arc reignition. If the resistance is not sufficient to extinguish the arc completely, there is a risk of arc reignition, which can lead to further damage and safety issues. Having examined the benefits and drawbacks of this method, where can it find its applications? The high-resistance method of arc extinction is widely used in various applications. This encompasses the followings. 1. Low-voltage circuit breakers. The high-resistance method is commonly used in low-voltage circuit breakers, where the arc energies are relatively low. 2. Molded case circuit breakers. The high-resistance method is used in molded case circuit breakers, where the arc is extinguished by lengthening the arc path and introducing high-resistance materials. 3. Miniature circuit breakers. The high-resistance method is used in miniature circuit breakers, where the arc is extinguished by increasing the resistance of the arc path. Next method we will analyze is low-resistance method of arc extinction. The low-resistance method of arc extinction is a technique used to extinguish electrical arcs in circuit breakers by reducing the current flowing through the arc medium. As we know, current usually flows through path of lower resistance. The same principle happened here. A low-resistance path parallel with the arc is introduced, which provides an alternative route for the current to flow, thereby reducing the current through the arc. As the current through the arc decreases, the arc's energy and temperature also decrease, ultimately leading to its extinction. There are several ways to implement the low-resistance method, including 1. Introducing a low-resistance shunt. A low-resistance shunt can be introduced in parallel with the arc to divert the current away from the arc. The shunt provides a low-resistance path for the current to flow, reducing the current through the arc. 2. Using a parallel resistor. A parallel resistor can be used to provide a low-resistance path for the current to flow. The resistor can be designed to have a lower resistance value than the arc medium, allowing the current to bypass the arc. 3. Designing the circuit breaker contacts. The circuit breaker contacts can be designed to provide a low resistance path for the current to flow when the contacts are closed. When the contacts open, the arc is formed, and the low resistance path helps to divert the current away from the arc rapidly. Having known this, what are the advantages of low resistance method? The low resistance method of arc extinction has several advantages. This include the followings. 1. Effective for high current applications. The low resistance method is effective for high current applications, where the arc energies are high. 2. Fast arc extinction. The low resistance method can provide rapid arc extinction, as the current is diverted away from the arc quickly. 3. Reduced contact wear. The low resistance method can reduce contact wear, as the arc is extinguished quickly, and the contacts are not subjected to prolonged arc exposure. Having recognized the benefits, what are the drawbacks of the low resistance method? The low resistance method also has some disadvantages. This encompasses the followings. 1. Complexity. The low resistance method can be complex to implement, requiring additional components and design considerations. 2. Increased cost. The low resistance method can increase the cost of the circuit breaker, as additional components and design considerations are required. 3. Potential for overheating. The low resistance path can potentially overheat, particularly if the current is high, which can lead to further damage and safety issues. Now that we have examined the benefits and drawbacks of low resistance method, where can this method find its applications? The low resistance method of arc extinction is widely used in various applications, including 1. High voltage circuit breakers. The low resistance method is used in high voltage circuit breakers, where the arc energies are high, and fast arc extinction is required. 2. Power system protection. The low resistance method is used in power system protection applications, where high-speed fault clearance is required to maintain system stability. 3. Specialized circuit breakers. The low resistance method is used in specialized circuit breakers, such as generator circuit breakers, where high-speed fault clearance is required to protect the generator. The last method we will analyze is current zero interruption method of arc extinction. We know that in AC systems, current passes through 0 2 times in one cycle. So, the current zero interruption method is a technique used to extinguish electrical arc in AC circuit breakers, by interrupting the arc when current crosses 0 point of AC cycle. This method takes advantage of the natural zero crossing point of the AC waveform, where the current is momentarily zero, to extinguish the arc. Let us explore deeper the mechanism of this method. When the circuit breaker contacts open, an arc is formed between the contacts. As the AC waveform reaches its natural zero crossing point, the current flowing through the arc momentarily becomes zero. At the current zero crossing point, the arc energy is minimal, and the arc is extinguished. After the arc is extinguished, the circuit breaker contacts must withstand the recovery voltage and prevent reignition of the arc. Now that we have understood the current zero interruption method, let us explore the benefits of this method. The current zero interruption method has several advantages. This encompasses the followings. 1. Effective for AC circuit breakers. The current zero interruption method is particularly effective for AC circuit breakers, where the current zero crossing point occurs naturally. 2. Low arc energy. The current zero interruption method takes advantage of the low arc energy at the current crossing zero point, making it easier to extinguish the arc. 3. Reduced contact wear. The current zero interruption method can reduce contact wear, as the arc is extinguished quickly and efficiently. Having examined the benefits, what are the drawbacks of the current zero interruption method? The current zero interruption method also has some disadvantages, including 1. Limited application. The current zero interruption method is limited to AC circuit breakers, and may not be effective for DC circuit breakers. 2. Dependence on current zero crossing. The current zero interruption method relies on the natural zero crossing point of the AC waveform, which may not always occur at the same point in time. 3. Potential for reignition. If the circuit breaker contacts do not withstand the recovery voltage, there is a risk of arc reignition, which can lead to further damage and safety issues. Now, let us see where this current zero interruption method can find its applications. This method is widely used in various applications. This includes 1. AC circuit breakers. The current zero interruption method is commonly used in AC circuit breakers, where the current zero crossing point occurs naturally. 2. Power system protection. The current zero interruption method is used in power system protection applications, where high-speed fault clearance is required to maintain system stability. 3. Industrial applications. The current zero interruption method is used in industrial applications, such as motor control and protection, where AC circuit breakers are commonly used. Having explored the methods for arc extinction in detail, let us analyze the arc extinction media used, and where they work perfectly. Arc extinction medium can also be called arc quenching medium. The arc extinction medium plays a critical role in determining the effectiveness of arc extinction. The most common arc extinction media include 1. Air. Air is a common arc extinction medium, particularly in low-voltage circuit breakers. However, air is not an effective arc extinction medium for high-voltage applications. 2. Oil. Oil is a popular arc extinction medium for high-voltage circuit breakers. The oil helps to cool and extinguish the arc, and it also provides insulation and protection for the breaker's contacts. 3. Vacuum. Vacuum is an excellent arc extinction medium, particularly for high-voltage applications. The vacuum environment helps to extinguish the arc quickly and efficiently. Lastly, SF6 sulfur hexafluoride. It is a gaseous arc extinction medium that is commonly used in high-voltage circuit breakers. SF6 has excellent arc extinction properties and is widely used in gas-insulated switchgear (GIS). Next one we will look at is factors affecting arc extinction. The effectiveness of arc extinction in circuit breakers is influenced by several factors, including arc voltage, arc current, arc length, and contact material and design. Understanding these factors is crucial for designing and operating circuit breakers that can reliably and efficiently interrupt electrical arcs. Let us quickly analyze them. 1. Arc voltage. The arc voltage plays a critical role in determining the effectiveness of arc extinction. Higher arc voltages can make it more difficult to extinguish the arc. When the arc voltage is high, the energy dissipated by the arc is also high, making it more challenging to extinguish. The arc voltage is influenced by several factors, including the arc length, the type of gas or medium surrounding the arc, and the temperature of the arc. 2. Arc current. The arc current also affects the effectiveness of arc extinction. Higher arc currents can make it more difficult to extinguish the arc. When the arc current is high, the energy dissipated by the arc is also high, making it more challenging to extinguish. The arc current is influenced by several factors, including the load current, the fault current, and the circuit breaker's interrupting capacity. 3. Arc length. The length of the arc affects the arc voltage and the effectiveness of arc extinction. The arc length is influenced by several factors, including the design of the circuit breaker contacts, the speed of contact separation, and the presence of arc chute or arc splitter plates. Lastly, contact material and design. The material and design of the contacts can affect the effectiveness of arc extinction. Contacts made from materials with high melting points and good heat dissipation properties can help to enhance arc extinction. The contact material and design can influence the arc's behavior, including its stability, duration, and energy dissipation. Contacts with good heat dissipation properties can help to cool the arc, reducing its energy and making it easier to extinguish. So, by carefully considering these factors, engineers can design and develop circuit breakers and other electrical equipment that provide safe and reliable operation, minimizing the risk of damage and downtime. In conclusion, arc extinction is a critical function of circuit breakers, and it plays a key role in determining the safe and reliable operation of electrical power systems. The effectiveness of arc extinction depends on several factors, including the arc extinction method, medium, and technique used, as well as the design and material of the contacts. By understanding the principles of arc extinction and selecting the right arc extinction method and medium, engineers can design and operate circuit breakers that provide reliable and efficient protection for electrical power systems. Here, we bring the class to an end. If you like this video, please share and subscribe to the channel to stay updated in all my latest videos. You can also check out my video on circuit breaker by clicking it on the screen. Thank you, and I will see you in my next class. Bye for now.